Alright, you guys, it's a little bit of a summary of the lesson we had today. 9:15. So, what's difficult for us is trying to figure out these formulas. So, I like to go to the third design. I think that really helps a lot. If I go to the third design, then I know automatically that n has to be 3. So, I'm looking for threes, any threes. So, how did Miriam do it? Well, Miriam looked at the figure as one big rectangle, okay? And then, where's my threes? Well, here's a 3. So, there's an n. But as far as the rectangle, she's looking at the big rectangle. She's going to see an n, a 3, plus 2. So, Miriam sees the n plus 2, right? And then look for another 3. I've got another 3 right here, right? And so that would be another n here plus another 2. So Miriam sees a big rectangle as n plus 2 times n plus 2. Now that's the big rectangle. However, if you then look at the big rectangle, you can't have all of it, so you have to get rid of these pieces. So these pieces, there's an n, right? That's an n because it's a 3 plus 1. There's a n because there's 3 of them plus 1. So you've got an n plus 1, another n plus 1. So here it is. You've got an n plus 1 and another n plus 1. So there's 2 of those. So she says, okay, if we subtract out those, we've got the big rectangle, n plus 2 times n plus 2 minus the pieces that should be taken out, this n plus 1 and this plus 1, and there's 2 of them. So that's how Miriam gets her way, or her formula, okay? Now probably an easier way is the way Matthew does it. So what Matthew sees is a square. In fact, we can see 1 square, 2 squares, 3 squares, and that's an n by n. So Matthew sees a square, so an n squared. And then Matthew realizes we have to add these 2 pieces in, okay? So again, if I go back to here, there's a 3, that right there's a 3, that's a 3. So we've got to add in an n and an n. So we've got to add in 2 of the n's. And then finally got these 2 pieces, a plus 1, which makes plus 2. And we always are adding 2 through all these patterns, okay? Now, are they the same? Sure, they're the same. If I were to verify it, I can take, is Miriam's the same as Matthew's, okay? And so if I take Miriam's and multiply it out, n times n is n squared, n times 2 is 2n, 2 times n is 2n, 2 times 2 is 4. I distribute the 2 through, and I get a negative 2 minus 2n, and I simplify. So I get 2n minus 2n makes just a 2n. 4 minus 2 makes a 2. So they are the same. So then the next question, so they are the same. Okay, verified it. They should be the same. The next question is, okay, well, we want to accommodate, we need our patio to be this big. It has to be this big. And so one way to do this is just start making them. So I started with 10 by 12. I thought that might be close to 125. That's going to be 120 plus 2. 122 is not quite big enough, so I went up 1. I said if I 10 by 12, let's try 11 by 13. So 11 times 13 is 143, then I add in the 2, 145. So we need to build this patio to fit all of our furniture. We'll have a little extra, but that's okay. This patio is still too small, just barely too small, but it's too small. So let's build our patio 11 by 13. Okay, and then on the back part of this page, we say, okay, well, what do we know? Okay, Miriam's tile has to do with a quadratic because it's an n squared plus 2n plus 2, or her formula. Either way, this is a quadratic. It's quadratic because of the n squared, right? Quadratic because of the n squared, okay? The secret is exponential. It's exponential because, we'll go back to it, we are multiplying by 3. 3 times 2 to the n, it is a y equals a 3 times 2 to the n. And finally, the backyard patio, well, I think that's linear. If we go back to the backyard patio, which takes us way back, but the backyard patio, 4n plus 4, there it is. The backyard patio is 4n plus 4 is linear, okay? So those are our 3 types of functions we're looking at, okay? Similarities and differences, well, the only similarity is the fact that they're all going to be polynomials. To agree. Nope, that's not even true. Well, they're different. They're all different. Similarities, I don't know much about similarities, but they are definitely, well, what does the book say as far as similarities? I don't see many. Yeah, I don't see many similarities at all. So anyway, that's what we have, and the homework was page 25 and 26. And we'll talk about a quiz tomorrow.